Good evening and welcome to our Mars Rendezvous live stream event. We're going to bring you Mars live through, we have access at the moment to 3 telescopes around Victoria. They're all ASV member telescopes. So we'll bring those to you shortly. But first I'm going to bring Perry Vlahos in with me. And good evening, Perry.
Hello, Mark. Good evening, everyone.
So we're going to have a bit of a chat about Mars first with Perry. He's going to show us some of the more important landmarks. And then once we've had a chat about those, we'll move into some live streams. But I'm also going to bring in the Deep Sky section, sorry, the Lunar and Planetary section director, Stuart. And he's turned his, we'll get him in a second, but while we're waiting for him, here he is, Stuart. How are you going, Stuart? So Stuart is the head of Lunar and Planetary section, and Stuart's going to help us answer some questions tonight as well. But what we'll do now, Perry, is I will bring your Starry Night screen in, if you'd like to get that up and going.
Okay.
There we go, and I'll make that large. And now Perry is going to give us some information on Mars.
Well, what a wonderful evening to be looking at Mars, Mark, and everybody there. Because last Tuesday, when in fact it was closest to us, it was such a miserable evening. Rain, clouds, everything you can think of, wind. But tonight we've got a beautiful sky, and if you want to quickly zap outside for a brief moment, you can actually see Mars with your own eyes. You don't need a telescope. You don't even need binoculars. And notice I didn't say a pair of binoculars, because the word binoculars itself means 2. So even without binoculars, you can just step outside and look towards the east, and low to the horizon, you will see a very bright object masquerading as a star, but in fact it's not a star. It has an orange, reddish tint to it, and it's the planet Mars, which over the next few days, or this week and next week, will be at its best to observe it, whether it be telescopically or just even with your naked eye. Now, just a little bit to the west of the zenith, that's the point directly above your head, is also Jupiter. If I zoom out from Mars here, that you can see, there's Mars, single red looking object in the eastern sky. But if we go higher up and we move over to this part of the sky, we also have Jupiter. So there may be an opportunity to have a look at Jupiter. I'll quickly center it, and we can see what sort of configuration it's in tonight with its moons. Well, there are its moons: Ganymede, Europa, Callisto, and Io. Io right here. And you can see the belts of Jupiter, the equatorial belts. If we zoom in even closer, that's what it will look like this evening. If you've got a telescope, an 8-inch Dobsonian, for example, you will at least get that view of Jupiter. And if the atmosphere is steady and you've got enough magnification, you may see it more like that. So Jupiter is available as well, and a little bit east of Jupiter is also Saturn. And if we go over to have a look at Saturn, let's zoom in to that. We'll see the magnificent rings and many of its moons. Here are some of its moons: Tethys, Enceladus, Dione, and Rhea, and this might be Titan, which is the only moon in the whole solar system that actually has an atmosphere. Of course, you know the old story when our astronauts went to the moon and they came back down. The question they were asked was, did you go to that restaurant on the moon? And Neil Armstrong said, yes, the food was good, the atmosphere was fantastic, but it just had no atmosphere. No, the service was fantastic, but it had no atmosphere. Damn, I got it wrong.
You missed it. You missed it.
Missed the punchline.
Next time. We'll get it next time.
So there we are. There's Saturn's, and the rings are about 270, maybe 280,000 kilometers in diameter. The disk of the planet, though, is quite a bit smaller than that. And it just looks unreal in a telescope. You think it's all done with smoke and mirrors.
The first time I saw that through a telescope, Perry, I swore somebody stuck a photo of it on the end of the telescope. It was that amazing.
You're right, Mark. A lot of people have a similar story to you when speaking about the first time they ever had a look at Saturn. But we're sort of, at the moment, padding a little bit, ladies and gentlemen, because the best time to view a planet, or in fact any celestial body, is when it's as high as it can get above the horizon, because then we're looking through less and less atmosphere. When it's close to the horizon, we're looking through a lot of atmosphere, and it's not as clear as what it is when it's a lot higher up. So over the period that we're going to be streaming, it will get higher, and we'll get the telescopes onto it so that we can have a live view. But here we go. All right. From a fair distance, we can see that Mars has two moons, Phobos and Deimos. Now, they're names taken from the Greek, Phobos meaning fear, and Deimos, this one, meaning panic, which were what followed the god of war, Mars, into battle, fear and panic. And so the moons were named after those Greek words from the mythology of Greece, of course. Now, the diameter of Phobos, it's both of these moons are captured moons, so they're not very large. Phobos is about 22 kilometers in diameter, and if we get in there and have a closer look at it, you will see that it's not spherical like our moon. There we go. There's the shape of it. It's not spherical because it's not large enough with enough mass to be spherical, and it's a captured body, probably an asteroid that got a little bit too close to Mars, and it was captured by the Martian gravity. And over here we have Deimos. That's even smaller. It's approximately 13 kilometers in diameter. And again, it's not a spherical object. You can see it's sort of a bit lumpy. Both of these moons, but first Phobos, are in such orbits that eventually they will fall onto Mars in a few thousand years' time. Phobos will actually hit Mars. So it's not going to be there forever. Well, forever is a relative term, but it's certainly not going to be there for as long as what our moon is going to be with us, for example. The other things to notice about Mars this evening, by the way, this is the south pole of Mars. This is a little bit of what may be left of its southern polar cap. And here's a tip for you all. As John Lennon said in Glass Onion, the walrus was Paul. Well, the tip for you here is that whatever season we're experiencing on Earth, the same hemisphere on Mars is one season ahead of us. And that doesn't just occur at this time, it's always the case. Whenever there's an opposition for the southern hemisphere, which is this half of the planet, they are now experiencing summer. We're in spring in the southern hemisphere or on Earth, so they're one season ahead of us. In the northern hemisphere, well, our northern hemisphere on Earth is experiencing autumn at this stage, but the Martian season in the northern hemisphere is winter. And so the Martian North Pole is aimed slightly away from the sun, which is over in this direction. And you can see that the South Pole of Mars is in daylight 24 hours a day.
It's not 24 hours a day, is it?
On Mars, it's 25 hours. So the Martian day is just a little bit longer than ours on Earth. Yes, very correct, Mark.
Well, I am an Aries, Perry, so I am a god of war as well. So you can call me Mars.
I will not touch that, mate.
I know how much you love astrology.
Moving on. Currently, if I advance the time, you will see Mars spinning sort of upwards from the bottom up. Do you see that? And you can see the time up at the top left is moving along, and it brings into view this feature right here, which is very difficult to see in a telescope. In fact, we didn't see it until we put the Mariner spacecraft into orbit around Mars, and that's why this feature is called Valles Marineris, which is not, I assure you, it's not a pizza, a margarita, or all the marine foods on it.
Marinara.
The marinara is correct. You can get it with spaghetti, but seeing it's round with Mars will stick to pizza. This valley, or this canyon, if you like, is a little bit like the Grand Canyon on Earth, except this valley is about 4,000 kilometers long from here to there. That means roughly the distance from New York to Los Angeles in the USA. And it is about 7 kilometers deep and about 200 kilometers wide at its widest. Now, the Americans like to call their little canyon the Grand Canyon, But I think there is no doubt, with the Grand Canyon being only, about 440 odd kilometers long and 29 kilometers wide and only about 1.8 kilometers deep, this really is the canyon, not the one in the USA.
So Perry, that makes this one around about 10 times the size of the Grand Canyon.
Correct, mate, Mark. Yes, no doubt about it. This is one of the most compelling features on Mars, but incredibly difficult to see in a telescope. As I said, we had to wait until spacecraft were in orbit before we could actually see it and make a note of it on pictures that we sent back from Mars. Tonight is a great night to be looking at Mars because it is clear, but a little bit later, though probably later than our stream, we will see the largest volcano in the solar system. Now, these are smaller volcanoes just here, but this one right there is Olympus Mons. And Olympus Mons is, again, an incredibly large feature compared to what we know on Earth. For example, on Earth, Mount Everest is 8.8 maybe kilometers high or thereabouts, but Olympus Mons is 21 kilometers high, an incredible height for a volcano. And if you could go back millions of years to watch this actually spew forth with lava and the contents from deep inside Mars, it would have been an incredible sight to behold. Fortunately, we weren't on the planet. If there was any life on the planet back then, and the jury is out on that, it would have caused a lot of problems locally. So they're the two main features I wanted to speak about on Mars. Maybe Stuart might have something that he would like to add about Mars. Stuart, anything?
Oh,
not really, Perry. I think you've covered most of the things quite clearly, other than that this will be the last year for opposition that in the southern hemisphere that we'll be able to see Mars clearly. The next opposition in the next 25, 26 months' time will be very much in the northern hemisphere and a lot smaller than this year.
Yes, that's something that we should explain, I suppose, and that is that as Mars and Earth's orbit are elliptical, if you can imagine Earth in an oval orbit, not as much as a football oval, closer to circular, but Mars's orbit is quite a bit more eccentric. And if that is outside of the Earth's orbit, you can see that as both the two bodies, maybe we can show that. Let me see if I can pull that up. Where are we? Solar system. Let's see. Planets and moons. No.
you turned them off.
Did I? Okay.
Yep.
Damn.
That's okay.
Let's try again. Planets and moons. That's not what we're after.
What are you after?
I'm trying to get a view of the inner solar system so that we can have a look at both of, hang on, we'll go here, we'll go favourites. I was in the wrong spot. Inner planets, inner solar system. There we are. So let's go to now, and here's the Martian orbit, and here's Earth's orbit. Now, currently, they are close together, but when Earth is over here and Mars is over there, you can see that physically those distances are much further apart here. So that is the worst possible opposition. Opposition, by the way, is the time when Mars is opposite the sun. So you can see easily here that Mars is in the opposite direction to the sun when we're looking from Earth. And that is when Mars is generally closest to us. If it was here, for example, then they would be slightly closer than what they are at this point. And when Earth is here and Mars is over there, it would still be an opposition because Mars would be opposite the sun, but unfortunately, it would be at a greater distance from us than what it is now. So it would appear quite a bit smaller in our telescopes, and it wouldn't be quite as bright in our sky. So if I advance the months, let's see, as we move around, and the next time the Earth and Mars catch up, it's a little bit further apart. And the time after that, let's see. Now that is getting quite a bit wider, and the next time after that, you can see there's a big difference from here to there. And in April 2029 will not be as good an opposition as what it is currently with this shorter distance here. Now, the other thing we should note is that the current distance is about, let's see, 62 million kilometers, 62.14. So it means that if we were to send a message via radio to Mars, it would take about 3.5 minutes to get there. And if we have a spacecraft on Mars, or let's look a long way into the future, if we had astronauts on a colony on Mars, they received our message and they wanted to say hi back to us, then their answer would take another 3.5 minutes. So we wouldn't hear anybody on Mars speaking back to us for 7 minutes. So it would be a somewhat dry conversation trying to speak to somebody on Mars when it takes that long to get an answer.
You'd have more time to tell your moon joke.
My moon joke.
You wouldn't make a mistake. All right, so what we're going to do now quickly is we're going to get Andy's stream going. I'll bring Andy in. How you going, Andy? He's probably got himself on mute. He has. We'll bring Andy's stream in.
How you going?
Perry, what we might do is once we've sort of run through Andy's stream and Noel's, if Noel gets his going, we might come back to Starry Nights and have some have another run through, because that was pretty interesting.
Good.
Right. Now, there we go, everyone. That is a live stream of Mars. Now, Andy, where are you located? So we can let everybody know. It's very cloudy in Melbourne at the moment.
How you going, everyone? I'm located in Langcoop, which is near the SA Victorian border. My closest town would be Edenhope, or the other side of the border would be Narracourt. So I'm sort of right on the western border, in border one skies here, and I'm using a Newtonian. It's a 150 millimeter, well, the old 6-inch Newtonian with a little guide camera. Pretty well. It's on there at the moment, and yeah, it's not the steadiest seeing at the moment. It's not the high in the horizon. I think I'm only about, say, 25 degrees above the horizon at the moment.
Andy,
And yep.
Could I ask you to explain seeing for everybody that doesn't know what it is?
What? Sorry, what was that? Sorry.
What do you mean by the seeing condition?
The seeing, yes. Well, there's at the moment, because it rained last night, 50 mil here, so there's so much moisture around, and above me there's been jet streams, and yeah, sorry, you might be hearing a few funny noises with my USB doing some strange stuff, but yeah, yeah. Yeah, it's just making Windows noises. Yeah, so it's just the turbulence in the air above me at the moment, and because there's so much moisture in the air at the moment, and also there's a fair bit of movement above, because we've just had a huge front, well, it's like a mini cyclone go straight over us at the moment, and yeah, so there's a lot of unsteady air above us, so it's pretty looking like laying down on the bottom of a swimming pool and looking at the ripples, and that's what I'm looking through. But the more Mars rises up towards the zenith, which is pretty well straight above me, it'll be it gets clearer and clearer and clearer and steadier. So all that movement you can see around here, and where my mouse is, you can just see the polar cap, the southern pole. I'll just zoom it in.
While you do that, Andy, we have a question.
Yep.
Perry, you'll be able to answer this. Wanda wants to know, the moons that you were talking about earlier, Deimos and Phobos, would they disintegrate before hitting Mars? How small might they get before they hit it?
That's a very good question, Wanda. We're not totally sure of the composition and the density of the moons of Mars at this stage. I think there are a couple of missions on the drawing board for a future landing on at least Phobos by one of our probes, and we'll know more about it then. So it's difficult to say without knowing the composition whether they would be torn apart by the Martian gravity, or whether there's enough density there to actually hit the surface as a solid. Stuart, do you want to add anything to that?
Are you there, Stuart? I think he's run away.
Stuart's out.
Oh, he's back.
It's Mac.
Can you hear me okay? Yeah, look, I think it is. I think it is a good question. I'm not sure whether the atmosphere of Mars is dense enough to affect either Phobos or Deimos if it was headed for collision with Mars. So yeah, it's a very good question. I've never thought about that before. So yeah, it's a bit of an unknown.
Well, the atmosphere of Mars is about 1% the density of Earth. So there's not a lot of gases in the atmosphere to create friction or ram pressure. So I would think there's a very good chance that a pretty large hunk of Phobos would actually hit the surface.
I know that they have to certainly take it into consideration when landing probes.
Yep.
and they've got they use the atmosphere for a bit of air braking, so to speak. But I'm not sure about when the moons finally get close enough in the next several thousand or so years, whether they'd break up.
One thing's for sure, though, Stuart. You don't want to be on that moon or Mars when it hits.
Definitely not.
Certainly not.
Thank you, Wanda. Great question.
Great question. Here we go. We have another question, Perry. Why doesn't Mars orbit in a proper circle?
Well, orbital mechanics is not my forte, but I would say that it may have something to do with the original formation of the solar system, and perhaps perturbations from some other bodies that could have influenced it at the time of formation. What do you think, Stuart?
He keeps muting himself.
Sorry about that. Yeah, look, back in Galileo's time in the 1600s, it was discovered that the orbits of the planets are not circular, but they're elliptical, and they're only slightly elliptical. I think it's just the outcome of the really what happened after the formation of the planets and the solar system. Really, that just turned out to be elliptical rather than circular. For whatever reason, I'm not sure.
Well, yes, that's the thing, Raquel, that none of the planets have a circular orbit, as Stuart has said. They're all slightly elliptical, some of them more than others, but no, none of them are in a perfectly circular orbit.
We have another very, very good question. And Darren, don't be worried about being a newbie. We were all newbies at one stage. I'm still a newbie, and I'm six years into being a part of the ASV. But Darren wants to know, why is Mars red?
Stuart, do you want to have a go at that, or do you want me to have a go?
Well, I think you might know more about that than me, Perry, but I believe it's because it has a high composition of iron ore, and it's basically a rust color that we're seeing. Does that line up with your description, Perry?
Yeah, pretty much. There's a little bit of oxidization going on as well, and that's what is giving it its slightly orangey color.
There we go. Nice, easy answer.
So in the future, we might have companies interested in going up there and mining the iron ore.
Well, yes, and if anyone,
well into the future.
If anyone's seen The Martian, by the way, a fantastic movie. It's about as close as you will ever get to physically being on Mars, especially if you're seeing it in 3D. Just looks amazing. And you will see in that particular movie that there's a lot of that orangey dust and color around the whole planet because of the iron content.
And you get blue sunsets.
So I've heard.
You do, yeah.
Which is a bit different. So there's a sun setting, you see blue because the way red's filtered out, and I think blue light cuts through. I think it's that way. It's something like that, but they've got images of blue sunsets on Mars.
As observed by one of the Mars rovers, or more than one of them.
Yeah.
Mm.
So we have another question.
An orange cat from Mars right here.
Oh, hang on. Oh, we had some people wanting to see your cat the other week, Perry. So there we go. For those who wanted to see, it's Joe, isn't it?
Joe.
Yep.
Joe, yeah.
He's got his mate outside, so he's going there.
He's going to have a party. Okay, so we've got another question here. When we get back to samples from Mars, can there be a danger of bringing it back to Earth? I.e., for instance, if there are any life forms, would it be 100% safe?
Yeah, that's another good question. And this sort of procedure was followed with the samples from the moon because we weren't sure what may be contained in them. And the same thing will happen with Mars. Everything will be quarantined and safely kept so that there's no possibility of anything managing to get out.
There we go.
Excellent answer, Perry.
It is. So we have, okay, so we were talking earlier about the iron oxide on Mars, and someone wants to know, does that mean that at one point it would have had water on it?
Stuart?
I think that they believe in the past that there possibly was lakes or oceans on there, but as the central core cooled and the magnetic field weakened and the atmosphere started to blow away by the solar wind of the sun, a lot of the H2O on the planet evaporated into space. I believe that's the theory at the moment. What do you think about that, Perry?
Seems pretty spot on to me, Stuart. If there's going to be, there's supposedly water underneath the ground on Mars. So future missions will probably try and access some of that water just to see that it is actually there. So there's lots and lots of evidence that indicates there was quite a bit of water on Mars, as Stuart said, in years gone by. However, if there's going to be any life that we discover on Mars, it's not going to be large animals at all. It'll be microbial size life. And there's probably every chance that it will be in fossil form rather than currently alive.
And also the temperature of Mars, Perry, I believe on the equator, on the hottest day in summer, it's only about 0. So any water there is liable to be frozen or underground.
Yeah. Pretty cold place, Mars.
It is. It's like, that's why they do a lot of trials in Antarctica to try and get people ready for and prepared for some of the conditions on Mars.
Yeah, living underground, getting used to it.
That's right, yeah. And you need to live underground as well because of the radiation factor, because there's no ozone layer and the magnetic field on Mars is very weak.
Yeah, so you won't see any auroras anyway. That's one thing you won't see. But you probably it's not a fun place to live, and the first people who go there are it's going to be a struggle. Especially you've got to try and they'll be in ice caves, trying to extract hydrogen and oxygen from water, from frozen ice, to make fuel and to breathe and try and keep warm.
Okay, we've got some other questions. What have we got? Here we go. What was the first Mars rover?
Oh, that was a long time ago. Was that, it was before Sojourner and Curiosity?
There was Viking that just landed, but it didn't rove around. It took some images, and there was even one before that, wasn't there, Perry, in the early 70s before and it sent back signals via facsimile, and it only lasted a very short period of time.
In fact, Mars is probably the planet that has seen most spacecraft, landers, and probes invaded from Earth. So there's dozens of them, in fact, now. So it's not Mars attacking Earth, it's really Earth attacking Mars. If you think of the old movie, Mars Attacks. The next one is going to be Perseverance, I think. And Perseverance will also be taking with it a helicopter drone, Ingenuity, I think it'll be called, landing on Mars in February. It took off in July. And
yeah, it's on its way.
Yep, well on its way. It's going to be about 6 months to get there. And that's during the closest period of Mars and Earth, when their orbits are aligned to their closest. So if you can imagine it, when Mars is at its farthest from the Earth, it would take a long, long time to get there. But I'm looking forward to February, because every time there's new instrumentation or new landers and rovers on Mars, we get fabulous new information and data, pictures coming back to us.
Yeah,
Sorry, go, Andy. I've got another
there's
question lined up when you're done.
3 on the way now, isn't there? There's 3 landers. I think it's one from United Arab Emirates, which is on its way, and a Chinese one, I think. So there's three off to Mars, all going to, all going to go through that 7 minutes of terror, as they call it, coming into land, where they've got to use everything they've got, from parachutes to air brakes to retro rockets and just hopefully they slow it down in time.
Yeah. Well, with so many craft that have been to Mars and landed on the surface, I think I heard somebody say that we know the surface of Mars better than we know what's in our deepest oceans.
Yeah.
There we go. All right, so we've got another question. Well, this one's probably very quick to answer. Is Mars on Netflix any good?
I quite like watching. I think it's reasonably realistic. It might not be 100% true to fact, but it's very close, I think. It's set in between something like 2035 and 2042 if we continue on with our current focus. It's I quite enjoy watching it. Have you ever watched it, Perry?
He's not there. I haven't watched it. I think he's gone to let Jove out or in, maybe.
He's in. No, sorry about that. What was
have you watched Mars on Netflix, and is it any good?
No, I haven't. I don't have Netflix. Some of you people must have a lot more money than me, because I can't afford to have Netflix.
It's all the
I think it's quite good. I think it's reasonably realistic, but for us to be in that position, I think the USA and China and a few other countries would have to get back to being more friendlier with each other before we could send create a mission like that. But I think it's reasonably, from my perspective, sticks to the facts.
Yeah, there's another one called Away at the moment, and it's a bit dramatized,
Yeah, I haven't watched.
Yeah, it's got a few bits of stuff of it. They've got to do the drama part, and make the story to make it a bit more friendly for the average punter. But Mars is quite good, because they keep on go back to little. It is quite close to what it would be like, and people do get sick and people do die, and it would happen. Going to Mars, risk of cancer would increase dramatically just being on the spaceship for 2-year return trip, and then actually living there and just going outside, and just it's a tough life. So we've got it good here, so we've got to look after one we've already got.
Where we are, where we're safe. We've got another.
And it follows people's mental health disorders as well from being confined in one area where they can breathe and live comfortably. So it is quite an interesting series. It's like COVID-19 blown out to the power of 20.
Yeah.
Very good analogy.
Looking at this image that Andy has got up, a lot of people may be wondering why it's so small. Why don't we get to see Mars as this huge thing, as we saw in Starry Night earlier in that program? Well, the simple answer is that Mars is over 60 million kilometres away. And it is only about, what's the size of it? About 6,500 kilometres in diameter, or thereabouts.
Slightly bigger than half the size of the Earth.
Yeah. So it's a long, long way away, and it would take a telescope outside of the Earth's atmosphere to give us a better picture or a steadier night to be able to do this. Because remember, it's not so much how large a telescope is when it's on the ground, but rather how steady the atmosphere is to allow us to view through it clearly. As Andy was saying earlier, it's like being at the bottom of a swimming pool with ripples at the top, trying to look up at the moon. But even so, we can still see some differences on the disk of Mars there. And you can see in the central area, it's a little bit darker than what it is around the edges. And down at the bottom there would be a little bit of morning mist or cloud there that looks a little bit whitish.
Whoops.
Yeah.
And that's up there. That's the southern pole, right at the tip. And just see it. Now, what I image this, so what I do is they call it lucky imaging. I'll take 10,000 frames. I've just taken a few before. So I'll probably do it no more than 2 minutes because of the rotation of Mars. And I might do 10,000 frames and try and get about 70 or 80 frames a second. And then I've got software which will pick probably 10%. So it'll just pick one frame, which just that millisecond, it was steady enough. And then it might miss 50 frames, and then it might pick one, or it might pick just the very top corner, which was steady, and put them all together. And here's one I did last week. So that's the sort of imaging you'll get from it. This tonight, I'll probably get, that sort of thing. And I've only got a little 6-inch scope. So really to look at Mars, you'd at least need, 14 would be good. Guys who've got 20, but then, like you said, you need steady seeing, and that's where people in the equator seem to do best with planetary. Because you've got the planet straight above, and the seeing's steady. It might be warm, but it's constantly warm, and there's no jet streams. There's no different.
Can you enlarge that a little bit more, Andy?
That one?
Yeah. Yep. So we can see the remnants of the South Pole up at the top there. Yep. So as summer comes into the southern hemisphere of Mars, the ice melts, and so the southern polar cap decreases in size and gets pretty small. But at other times, when it's, say, early spring or late winter, it can be quite a bit larger than that and stand out much more prominently. And if, Andy, you want to show some of those markings along there, under the polar cap, so observers could see some of those markings changing colour as it went from winter into spring and summer, and they thought perhaps that may be vegetation starting to grow because of the melting of what they thought may have been water at the polar cap.
Okay, now, Perry, we have a question. Hypothetically, if humans did start mining Mars for iron, could they cause enough damage to take enough ore to significantly impact the solar system?
Or they would have to take out a
lot
amount to make any sort of difference. So the short answer would be no.
There we go. We've got some other questions as well. All right, what's the difference between our moon and Mars's moons, and how long will they last for? So we kind of answered part of this before. So, Stuart,
I think our moon is still considered to have arisen from a very large impact into the Earth, and so our moon is considered to have been part of our crust broken off and formed into the orbit, whereas Mars moons are considered to be captured asteroids, and they're considerably smaller, and they don't even look round. They look like potato type of shape. They're very, very ununiform.
Yep, correct. The other difference, of course, is because they're so small, they're unable to have a spherical shape like the moon. And one of the reasons why many bodies in space and in the solar system appear to have spherical shapes is because gravity is pulling into the core equally from all sides. So that creates a sphere.
There we go. All right, so we've got, here we go. So where can we watch or get more information on the rovers? I think most of them are, NASA's got a lot of information on the rovers.
Yeah, on the NASA website.
Yeah, definitely.
And the original, somebody asked and we weren't sure, but I said Sojourner was the first one, and I've just checked, and it certainly was. That was the first one, and it was particularly small compared to what we're sending up there now, which is about the size of small cars. But the first one that we sent up was only about the size of a briefcase, maybe a little bit larger.
That's pretty small.
Yeah. So, well, we're getting better at it, Mark.
Okay, what
There's also been a few spacecraft that have failed, and
we don't
through various reasons. And they've had either a collision or they've missed. So yeah, as time goes on, people get better and better at their calculations and
all right,
getting rovers to land and also there's not just rovers. There's spacecraft in orbit taking photographs continuously.
So I think we've got another view of Mars from a patchy ringwood. from Ron's. So we'll bring Ron's in, and pop Andy out to the back for a second now. We'll bring Ron in. So this is Ron's equipment. So Ron, what are you using?
Okay, thanks, Mark. Yeah, it's pretty patchy at the moment. There's cloud going over. I can barely see it visually through the sky, and so you can see it flaring up on the screen there because I've got gain on. I'm using an 8-inch Schmidt-Cassegrain telescope, which is a little larger in diameter than Andy's, but mine's got the little secondary mirror obstruction in the centre at the back, so probably not much difference in light capturing ability. And I'm using an ASI 290 MC camera on that. Last week when we were on having a live view, I had a 2.5 times magnifier, a PowerMate on my scope. Tonight I've taken that off because I thought it'd be, with the wind that we had earlier, it'd be better to just go with the native focal length of the telescope, which is about 2,000 millimeters. So it's operating at about f10. But you can see that image is flaring in and out because the cloud's going across. It might be a bit better in a moment or two because the cloud band it's quite thin, but it just keeps moving in front of the planet.
So what we might do, we might come back to you because Noel's got what I can just barely see down on my bottom of my screen. He's got a cracking view with his equipment. So I'm going to bring his one in. We'll have a look at Noel's. We'll come back to you and Ron.
Okay.
So Noel, we'll get yours going and I'll get Noel in. So if you can sharpen that up for us at all, Noel.
It's quite low, I guess, in the horizon. I've got a new electronic focuser on my scope, so I'm able to tweak it a bit. You can just see the polar cap popping in here. There's a little glimpse of white that isn't my mouse cursor.
That looks really good, Noel.
Yeah, that's a pretty impressive image, I've got to say.
Yeah. So what?
You can see the seeing is a bit variable, but it looks it looks very, very.
So
yeah,
I'm running.
the polar cap is
Yeah,
popping,
you can see it's
right
popping in and out. Yeah.
So this is a 180 mil Makrotov with a 2 times PowerMate on the end of it. I took this photo a little bit earlier tonight, just to. I guess because I haven't had this rig running before, so if anything happened, I wanted to know what it looked like. And this is a EQ6R equatorial mount, so I'm controlling this remotely in my backyard, and that's why I've come up with an electronic focuser I can put on there, so I can tweak things without having to move away. But yeah, I'm kind of happy with how that's coming through. It'd look much better in about 4 hours' time, I think. But
I'm not going anywhere. So we've got a question here while I've got this one up. So Jamie Lee wants to know, what is the composition of the poles on Mars?
carbon dioxide ice in the main.
Yeah, yep, I agree.
There we go. Very simple answer.
In fact, most of the Martian atmosphere is predominantly carbon dioxide. It's probably 95% carbon dioxide, and the rest, maybe nitrogen, a couple of percent, 2 or 3%, and yeah, not much oxygen at all. So it would not be a hospitable place for anyone from planet Earth that's used to breathing nitrogen and oxygen, which is our atmosphere. So we would have to take a lot of a lot of equipment to help us breathe on Mars, or somehow to be able to manufacture it on Mars. Otherwise, life, just wouldn't be possible for humans on Mars.
Well, that leads into a question we've got, Perry. With Mars being a very cold planet, does it mean there is no living microorganisms there?
Well, we don't. The simple answer is we don't have enough information yet to be able to definitely say one way or the other. But it would appear that the odds are probably not in favour of life currently on Mars, whether it be on the, well, definitely not on the surface, but perhaps underground. What do you think, Stuart?
Yeah, I think that's the big burning question, isn't it? Is there life on Mars or not? And we really,
And people,
we just don't know. We just don't know.
no. And remember, David Bowie was the first one to ask that question.
He was. He sang about it.
I'm not surprised that you said that, Perry.
Actually, today is a terrific date, as you would know, Stuart, to be looking at Mars, because it's also John Lennon's birthday. So
I know it is. Yeah, that's it is indeed. Yeah.
And also Carl Schwarzschild.
So now you're leaving me in the past there, guys. I'm not old enough to know that last one. I can't even say his name, Perry. So we've got another question. We'll move on from the music that I don't understand.
No, it wasn't music. That was an astronomer.
Oh, there you go. See, that's how little I know from that.
Yeah.
Jamie wants to know, if we put a colony on Mars, would we be able to grow anything in the soil? I mean, Matt Damon did. He grew potatoes.
Well, it
would we have to bring dirt from Earth?
Well, if there's any truth to the movie, and I have serious doubts about that, you would need a lot of human waste products and some good, Pontiac potatoes.
I'm not sure one man could produce enough human waste for what he did, considering he had such small supplies of food.
It was a great movie, but whether it was possible, I agree with Perry. We just don't know.
Well, for starters, there could never be a big enough or a forceful enough storm on Mars with 1% of the Earth's atmosphere to be able to knock over a spaceship. So
actually, yeah,
the whole
true.
premise of the movie is probably not good to begin with, but hey, we can let our imagination go wild. That image is getting better all the time, Noel.
It is, isn't it? So
Yeah.
we've got another question here. What would we take on the trip to Mars to begin the process?
Well, a big shopping list, first of all, before we leave, just to make sure we don't forget everything that we need. But essentially, humans will need some of the following. We will need food and water in some form or another. We will need something to breathe, oxygen, nitrogen, etc. And we will need to be able to protect ourselves from solar radiation and cosmic rays. Then we would need to protect ourselves from the cold. And it would be a good idea to take a lot of Mars bars up there as well.
We may
on that show on Netflix, they actually discover a cavern, an underground cavern with a water ice supply for their water needs. So you definitely need to find water on Mars, because water is very, very heavy to take with you. So you need to have a supply of water there, not just for drinking, but for manufacturing rocket fuel.
Yeah. Yep.
So we've got a couple more questions. Actually, I thought we did. No, someone's written an answer instead of a question. My apologies. I'm gonna jump off yours there, Noel. I'm gonna go back to Ron's. He's got quite a nice image. We can really see that polar cap.
Oh, yeah.
Very
So,
nice.
yeah, it's very, very nice, that polar cap.
Now, one of the things that people can look out for is you can see that the image is jumping slightly in and out of focus. Well, that's not actually anything to do with the telescope or the optics. That's, in fact, the steadiness of the atmosphere. So whenever the atmosphere steadies up for a split moment or a second or so, the image of the planet sharpens up and it becomes a sharper focus than what it is at other times when it's not steady. So what Andy was saying earlier is that if you take a lot of images, you will, and many per second and hundreds per minute, you will get some images which are steadier than others, and then you select all the steady images to get the best possible view. But it's not easy to do that if you're getting a live image directly from a telescope, and you just have to take the good with the bad. Some moments it'll be steady and clear and sharp, and other moments it'll just be fuzzy and unfocused.
And that's why we have to use that technique that was mentioned before. I can't remember who mentioned it, called lucky imaging, where you take videos of the planets and then you analyze them later on and you stack all the sharp frames together to create a sharper view of the planets. But unless it is very good seeing where it's steady, you're not going to get a really, really sharp image. But tonight doesn't look too bad.
Point out the polar cap again, please, Andy, if you can.
That's Ron.
Oh, it's Ron. Sorry.
Here's my mouse pointer at the cap now.
Yep. So people should be able to notice that there's a slightly whiter area there at the top or
Just
to the right, which is where the South Pole is. Now, through the course of the evening, the planet will get a little bit, or the South Pole will get more vertical, and then as it sets in the west, it will move towards the left side of the disk. But if you can recall a little bit earlier, it was almost directly to the left when we began, and now it's a little bit higher.
Moving its way up.
Yep.
Question for Stuart. I've seen spectacular images of Jupiter and Saturn. Have you imaged Mars or any other planets? And if you have, can we see an image of it, Stuart?
Oh, thank you, Tara.
Even if I have to teach you how to share screen live while we stream to the public.
Oh, look, I haven't had much luck with Mars this year because Mars, compared to last year, has moved northerly across what they call the north equatorial zone into the northern hemisphere more. So the problem that I've had is that Mars in the sky has moved behind this giant tree, which blocks my view of Mars from my observatory. So now I've had to go mobile again, and I've only had one chance to view Mars, but I've actually got some long service leave booked next week for a couple of weeks, and I plan to do as much imaging of Mars as possible, and then you'll see some of my Mars imaging. But at the moment, I've only got one pretty ordinary image of Mars.
Well, we will wait for your processed long service leave images of Mars, and once you've done them, we'll share them on our Facebook page for everyone to see. So,
yeah, no, I've only got Jupiter and Saturn at the moment, so Mars, I haven't done a lot of Mars yet.
But you got some great images of Jupiter and Saturn, which we've shared on the Facebook page as well before. So,
Thank
Ron,
you. Thank you, Mark.
Mark wants to know what are the details of the telescope you're using at the moment.
Okay, it's a Celestron Edge HD 8-inch Schmidt-Cassegrain, and it's sitting on an alt-azimuth mount, an evolution mount. So it's tracking the sky a bit differently to what Andy's does, and which is on an equatorial mount. But it's fine for planet observing and photography, but not so good for deep sky stuff where you've got longer exposures. It's a 2,000 millimeter focal length, this telescope. And the camera is a Zwo ASI 290 MC, which has got a very small sensor, which is ideal for planetary work. Can be a challenge sometimes to get the images located, especially if you've got a BOA or a power mate on your telescope. You're looking at a very small part of the sky. So yeah, sometimes it takes a while. It takes a bit of luck at times to get it in the centre of the field, but it's worked out fairly well tonight.
Okay, so we've got another question. When is the next time Mars will align to the southern hemisphere of Earth so we can watch it again like now?
Oh, that won't occur until, well, this observational window is really, the best of it is about 4 months in this apparition. An apparition is what astronomers, it's not a ghost, it's what astronomers call a viewing period or an appearance of a particular object. So for this particular apparition, the best viewing would have been from August up to about, would you say, this late December, Stuart?
Yeah, look, I think so. Yeah, it's because it's gone more into the northern hemisphere. It's going to be a shorter viewing period. But yeah, I agree with you, Perry. Yeah,
and we won't get it looking as big as this after this window of opportunity lapses for maybe another 14 or 15 years. It won't be as good as this again.
Yeah, I'm not sure how long it is, but it is going to be a considerable period of time.
About 2034, 2035, I believe.
You can see that there's a bit of cloud going over in front of my scope at the moment. The image is deteriorating at times. That's cloud.
We might jump back to Noel's because his is looking quite good. And
okay.
Would any of you, if given the chance, choose to be the first commuter mission to Mars? That one's for you, Perry, because I wouldn't go. I'm happy being here on Earth.
Well, I'm not too keen to sit on rocket fuel, actually. And
see, I've got no problem doing that. I've got no problem sitting on rocket fuel, going up to space, seeing it, and then coming back.
Well, it's the coming back bit that's the difficult part.
So would you go? It means you wouldn't go.
No, I wouldn't go.
Let's on mute. There we go. Well, let's unmute.
I think I'm too old to go to Mars.
Old to go to Mars.
If I was like, I'm in my late 50s now. If I was in my early 20s, yeah, maybe. I don't know.
Although they don't generally take astronauts in their 20s because they want people that are more stable mentally and emotionally. So generally, they do take people in their 30s more than 20s.
Well, they definitely won't want me if they want stable people. Noel, would you get on a rocket and go to Mars and not come back? Or would you, if you could come back? So, if you could come back, would you go to Mars?
it'd be a heck of a buffet that they'd have to have on board, because that's
Heck of a buffet.
I mean, I went to the States last year, and that flight, that was just enough to make me think, like, regardless of the political situation and everything else that's going on there, that flight alone was enough to make me think, not again. But I think in zero gravity or whatever, then it's going to be a different experience. You're not going to be quite so cramped. I think I'd miss my dog. And I guess if I could take Sarah, but yeah, I think I'll stay put. There's too much good stuff going on here. Someone else can send me pictures and stories about Mars.
So we just jump back to Andy's for a second because he said it was getting pretty stable there. So might bring Andy back in as well. And Andy, while we're looking at your image, would you go to Mars?
Definitely.
Yeah.
What could go wrong?
Well, we wouldn't have your live streams anymore. We'd be clouded out all the time. So
yeah. No, I'd go for a look. I wouldn't want. It's a long haul, and the zero gravity would knock you around a fair bit, and it's not good for your bones, and you get the male will get the blindness. That's quite a common occurrence. You might go blind in one eye. I think it's your right eye. I think
for men, is it?
For men, is it? Is it right eye or left eye? One of the eyes go. You get a blindness, and they're not too sure why.
Well, if they're Collingwood supporters, they've already got that. So.
All I have to say, Perry, is what's it like not making the finals?
It's not good, Mark. I can tell you.
There's a series of books. There's a series of books called Red Mars, Green Mars, and Blue Mars by Stanley Robinson, and that's very interesting books, and it's quite talking about landing on Mars in 2040 or 2050 or something, and what they do beyond that. But yeah, you'd have to dedicate your life to say, well, if I'm going to Mars, then I'm probably really just not going to come back.
Yeah. And Elon Musk, he'll do that. He'll send people to Mars pretty well for a one-way ticket, just as adventurers. There's a few other. And NASA are going the moon base first to just test it, test what it's like living with no under our protection of our magnetic poles, and if something goes wrong, you're 4 days away. That's probably the better system. But Elon Musk they're going, direct approach, and he'll give it a go, I think, and he'll find plenty of people who will just jump on board. But the moon base is a safer bet. It's a good test to see how we go living off the Earth, and how we're going to live, not protected from solar storms, and but 4 days away, so it's not too bad. You can come back, you can get a rescue.
Well, Mars ain't the kind of place to raise your kids anyway.
Well, here's a good one. Here we go. Lee Green, who I know has recently joined the ASV with his wife. 6 months in ISO life working at home, I could do with some zero gravity to help get rid of some of the weight I've put on. I'm with you on that one, Lee.
Well, on Mars, it's only like 1/3 gravity of Earth, and the Moon is like 1/6. So you actually are lighter on Mars, or or even lighter on the Moon.
But you could be larger and still be lighter.
That's true.
So you can eat more. You can eat more. All right. So I think Ron's got some clear skies going where he is as well again. So we've got a nice large image coming through. So we've got some good views of Mars between these three telescopes. So one of them is in Ringwood. It's my old stomping ground. Ringwood. And so the skies have cleared up. And we've also got Andy's over near the South Australian border, and we've got Noel's telescope up near the middle of sort of Bendigo way. So 3 telescopes set from the middle of Victoria across to the west, and we've got some great views of Mars tonight. We've got the polar ice cap there and some good detail coming through on each of them.
Yeah, the clouds are just going across Ringwood again at the moment, so it's looking a bit speckly there.
It's all right.
It's rainy.
A little bit rainy.
Yeah.
We might jump across to Knowles one again.
That looks clearer.
Yeah, it's much clearer up there. Got a good view there, Noel. I think Andy's got the best view, but Noel's equipment's probably just a little bit better, so it's a bit bigger. But that's some good detail there. Going to blow it up. You can see that cap popping in and out there.
I was speaking with Barry Adcock the other day, good friend of mine who was the section director of the lunar and planetary section for like, I don't know, 35 years. And he was saying that when Mars is in opposition and in the best place for the northern hemisphere, the oppositions are very small compared to the southern hemisphere where they're quite large. So we've got a huge advantage in the southern hemisphere for Mars oppositions.
That's true.
It's very interesting.
Is that always the case?
Yes. Yes.
I believe so, yeah.
Yep. Whenever Mars is at its best opposition, which occurs maybe, what is it, every 16 years or so, Stuart? Is it about that?
Oh, look, I've really only been following it since the early 2000s, but you're probably right, Perry.
2003 was the best one.
That's right.
And the last one was, what, 26 months ago? So
Yeah, that wasn't too bad.
So, yeah, it's about that. So whenever that occurs, Mars for us is in the southern part of the zodiacal constellations, the southern ecliptic. So it means it's in Jupiter or Ophiuchus or Sagittarius or Capricornus or Libra. And it gets quite high for us, whereas in the northern hemisphere, it's not quite as good.
No, and the problem that we had at the last opposition, if you remember, Perry, was that Mars had this damn
dust storm,
and you couldn't even see anything other than the polar cap for a couple of months.
Yeah, that was quite unfortunate.
Yeah, that was a massive global Mars dust.
Yeah, that was just after I bought my telescope and was getting into it. I thought, oh, this is
So just a quick one, guys. Just going back to the whole gravity thing, because everyone's still talking about gravity in the chat there. There are some treadmills around that you can get on, some zero gravity treadmills, and you can run on them as if you're running on Mars or on the moon.
Right.
It'd be pretty interesting to feel what it's like to run on one of the, on Mars.
Okay.
Yeah.
Well, Mars and the Moon aren't zero gravity, but they're less than 1G.
It's called
they're
a
less
zero
than
gravity.
1G.
Yeah.
Yeah. Okay.
You can adjust it to suit, so you could set it to Mars's gravity and run on it.
Oh,
so
cool.
That would be pretty interesting. So what?
How about the vomit comet? Does anyone go on that?
The vomit. Is that
comet.
is that like the chuck it bucket?
Yeah, it's a NASA training plane, and they do a series of parabolas, and
up, down. Yeah.
Yeah. Stephen Hawking went on that.
He did, didn't he? Yeah. Yeah. So what are we doing here, Noel? What are you playing around with?
Just settings.
Yeah, I'm just tweaking the focus in and out.
You've suddenly gone like double size.
Yeah.
That looks
Yeah.
pretty
What
good.
I've done
That looks very good.
is I've really just narrowed in on an area of the chip so that by concentrating on this region of interest on the chip, the system can disregard all the data from the rest of the chip, so I get a lot more frames coming through. Although I've capped it, I just didn't want to overload things a bit here. But also just playing with the zoom levels, just trying to get a feel for what's going to look good on screen, adjusting the stretch on the image so I can play with the how the data's being stretched, so we can try and sort of milk a bit of contrast in there. But it's just a bit of a fiddle around to try and get something that looks good. But yeah, the focus is jumping around a bit.
It still looks pretty good.
Yeah, no, this is the best view of Mars I've had in any of my gear, so I'm pretty happy with it.
It does. It looks very good.
All right, so
I see Andy's got a pretty bright shot there.
Yeah, I might jump to. I saw his. I'm going to jump across to that. There we go.
I'll just knock the gain down a bit. It's whoops, too much. Oh, come, that's better. I've got 0 gain. I'm just trying to tweak it just that little bit too. It's the same thing with my settings here. Trying to, like you're saying, trying to get contrast. It's tricky. And I'm not in the middle. I've just got to. Okay.
Beatrice would like to know what is in the core of Mars, the outer layer in the middle. I'm pretty sure the middle is like a chewy caramel. I couldn't resist.
Did you know that on Mars they eat Earth bars?
Perry, would you like to explain what's actually in the
that.
middle of Mars? We can't trust Stuart. He's in bad joke mode.
There is a core on Mars. I think it is iron, and there is. It's a lot like Earth. There is a crust, and the mantle, and of course on the surface it's much the same as Earth, except nothing is physically growing. But that is what Mars is composed of, an iron core.
Yes. So there's a we've got a liquid outer core and a solid inner core.
So does anyone know what stops the magnetic field? I mean, I know it's a not Coriolis effect.
There's no dynamo. There's no dynamo effect.
Yeah, I thought it was Coriolis, but yeah, dynamo effect, and it's lost its magnetic poles. But
because it's cooler and it's less got less mass than the Earth. It's not the core isn't as active as the Earth, so it's lost that magnetic field that stops the atmosphere and that from getting blown away from the solar wind.
Yeah. And
so if you're going to live there, you're going to need to live in a shelter, and you're going to need oxygen, you're going to need water, you're going to need food. So it's not going to be very easy.
But don't take your compass, because it's not going to work. It
won't work at all, will it? No.
I think it's very, very weak. There is a magnetic field there, but I don't know what how a compass would work there. I guess I don't need to really know.
So Kevin wants to know, as Mars travels around the sun, how many years will it take to be close to Earth again? Is NASA currently attempting to land a probe on one of the Mars moons to bring back samples? There's a double whammy there.
Answering the second question first, there is a plan on the drawing board to land a probe on the moons, but it hasn't been green lighted as yet. And as for Mars traveling around the sun, it takes about, before we line up again, it's about 16 years. So the last one was in 2003. Sorry, the second last one was in 2003. 2018, we were pretty close. And the next one won't occur, let's see, 28, yeah, about 2034 or 35.
Not that long to wait.
Yep.
That's for a close one.
Yes, for the closest one. Yep. And
We still line up every 2 years and 2 months or something.
yeah, but the distances are different. But hopefully
Definitely.
by 2035, actually, no, there's not much chance. I thought my team may have won a premiership by then, but it's pretty unlikely.
30-25 maybe, Perry. So what are we doing there, Andy? What's with the crosshairs?
Oh, that's the center of my chip. And I'll just put the crosshairs on, and because I haven't really done a proper star alignment and my pole alignment's right out at the moment, so I've got a bit of drift. So every now and then I'll put the crosshairs on, and just remotely control it back to the center of the screen. Oops, left, wrong, that way, and you'll get drift. And then back off to try and get at the center.
Wonderful. All right, so we might take a quick peek at Ron's, and we might start to wind things up a bit because it's just clocked 11 o'clock, and I just realised we've been going for an hour and a half.
Oh, really?
Time flies when you're having fun.
Yeah, it has been fun.
It has.
So,
yeah.
Oh, you've got some more cloud coming through, Ron. I can tell.
Yes, there's a bit of cloud coming through. It's right on the edge of a band of white fluffy cloud, and it comes out of it, and then all of a sudden it comes. You think, oh great, it's disappearing. Then it just materialises out of nowhere again. It's beautiful over where Jupiter is.
So in the next few weeks, people should get out and try and observe Mars, because it's going to be the best that it's going to be for quite a while.
Yes, I'll certainly be making the most of it, because there's another 20 years or something before it's this good again.
I'll be trying very hard. I'll be trying very hard with my phone to try and take some decent images of Mars. I've got the other planets sorted out, but Mars is my nemesis at the moment. It doesn't want to play ball with the phone just yet.
You've been doing pretty good, Mark.
Yeah. My Jupiter recently I was really happy with that one. Probably easily the best I've taken, and considering it was sort of suburban Melbourne skies as well. That was a cracker single click, that one. Don't think I'll do that good again.
Mark, can I give you an extra tip?
Go for it. Always happy for advice. Everyone else, pay attention.
Does your scope have a plastic lid for the front?
It does, yes.
Does it have a hole there?
No, but I can make one.
All right. What I'm talking about is an off-axis mask there, where if you can get a straight path for the light to the mirror, you will get a sharper image. It won't be as bright, but it will be a little bit more focused.
Yeah, didn't even think about that, Perry. Thank you. There we go. There's a tip.
Welcome.
I might have some better images come the next fortnight then of Mars.
And that will work with all the planets and the moon and double stars, but don't try it on galaxies or nebulae.
It won't work.
Well, you're just making them dimmer.
Yeah, it won't work. I can't do galaxies and nebula from my backyard with my phone because I don't have timed exposures. It's single click, so
Sure.
I can get
And all
galaxies from the dark sky site through my phone through the small telescope because it's so dark, but not from my backyard. What were you going to say, Stuart?
All it costs is just a piece of cardboard.
Yeah. Yep.
It's a very good experiment. I quite like it.
Yep.
I've got one. I don't know if you can see this in my. It's my cap on my scope. It's got two.
Hang on. We'll jump back out. Here we go.
Yeah.
Yeah, I don't have one of those. We'll make.
And it's got a cap which goes on. So you're talking about one of these, are you?
Yep.
Yeah.
Yep.
Yeah, I think that's designed really for solar, for looking at the sun. But what we're talking about is an off-axis mask where you make an off-axis circle that slightly misses the secondary, and it probably brings the primary mirror down to about 40 or 37, 38%.
Gotcha.
And it increases your F ratio, and under some circumstances it can give you a crisper looking view.
Right.
Yep.
I'll give it a go.
And it doesn't cost anything. It's just a good experiment.
I don't know if you can see mine.
Yeah, hang on. We'll make you. Let's bring everybody back again, and we'll. There we go.
Here's mine for my telescope.
Yeah, so the 25-inch has a lovely big metal one that we use.
We need to make one up. We need to make one up for the 40.
We do need to make one for the 40-inch. Yes,
That'll be a big sucker.
So there's a reason to join the Astronomical Society of Victoria, people, to be able to have a look through the 25-inch telescope and the 40-inch telescope that we have when the site opens to the to Melbourne again. That is,
which is the biggest amateur telescope in Victoria.
It is. So
professional. It's just bigger.
It's just the biggest. It is. It is. It's huge. It's so the 25 inches. What's that in centimeters, Perry? So the one
25.
40 inches, nearly a meter, or just on a meter. So the 25 is about 60 centimeters, roughly.
Yeah, about that. 60.
Yeah, about that. So the mirror is about 60-ish centimeters for the 25-inch, and the 40-inch is about just on a meter. The mirror. So the
1.02 meters, roughly.
Yeah. So the telescopes themselves, when they're standing vertically, standing upright, are around about 3 meters plus in height. So they're pretty damn big telescopes.
Okay.
Now, what have we got? So I did ask Noel to finish off with something. What have you got there, Andy?
Something with too much gain at the moment.
Yeah, I'd say that's Jupiter, isn't it? I can't hear him. He's muted.
Sorry, I just tried my I put my mask on and I tried it and it didn't work. So
you're on Mars. Okay. I'm like, that looks bright like Jupiter. I did ask Andy, Noel, to move to something special. I don't know if he has or not. Have you, Noel? Something just to finish on, something fun?
Yeah, I'm trying to find Jupiter, but it's real needle in the haystack kind of thing with this focal length.
Okay.
It's been
I'll see if I can find it.
A bit of fun.
Oh, there we go. So we might just finish on Jupiter just for a bit of fun, everyone. We've spent... what was that, Perry?
Or Saturn.
Or Saturn. Yeah, Jupiter or Saturn. Actually, Saturn.
Yeah, Saturn might be good. We haven't seen Saturn yet.
Could we do Saturn? Let's finish on Saturn.
Let's see if I can find it.
Saturn may very well be a very unique planet in the whole galaxy. Who knows?
Well, the rings. I mean, I'm sure it's 180,000 kilometers wide, but only the average plate.
270, actually, Andy.
How much is it? Sorry.
270,000.
But it's only
I've got Saturn.
30 meters thick in the average.
30 to 100 meters thick. Yeah. That's
And that's
an astonishing thing.
that's the straightest thing in the known universe, pretty well. But
And
as
when
we can
they
see,
go edge on, they disappear, I believe, for up to a month, and I'm hoping to image that.
has anyone imaged the when Saturn's opposition and you get a real flash? It's supposed to be really bright when the sun hits it directly. You get a it's only a short period might only be 15 minutes, 20 minutes, and you're supposed to get a direct reflection off the ice crystals.
No, it was cloudy last time that happened.
There we go. Noel's got Saturn. That's a very good image of Saturn live streamed.
Yeah.
Very, very, very nice.
Wow.
Yeah.
See at the back of Saturn where Saturn it causes a shadow on the ring. When Saturn's at opposition, there's no effect like that. And before opposition, the shadow is in the opposite side, on the right-hand side. And then after opposition, the shadow goes to the left-hand side.
That's seriously impressive. You could almost...
You can see Cassini.
Yeah, you can see the Cassini division there.
Someone should explain what the Cassini division is.
Well, I kind of know, but I don't want to make a fool, so I'll let you do that, Perry, and then I'll know if I'm right.
No, Stuart should do this one.
Oh, Stuart, there we go, Stuart. What is the Cassini division? I'm pretty sure I know.
There's a very large gap in the rings, which people, when they're imaging Saturn, they look for because it's a good indicator whether you've got good or bad seeing. And the image, there's a gap in the rings kind of 3/4 of the way to the edge. And it was discovered by an astronomer known as Cassini. And I think he discovered it in about 1660 or 1670 using these massively long refractive telescopes. And it wasn't until Isaac Newton and a few other guys got onto optics in the later 1600s and the early 1700s that they started to understand telescopes more. But Cassini was the first to view the gap in the rings through this single lens, massive long telescope known as an aerial telescope.
At Paris Observatory, wasn't it, Stuart?
I don't know where it was, Perry, yeah, but that's quite possibly correct.
He was of Italian extraction, but he was working at the Paris Observatory.
Yeah, yeah.
And there's also another smaller clearing within the rings, and that's the Encke division.
Very, very difficult to see. You have to have very, very good atmospheric seeing, and you have to have a lot of Saturn data before you can actually view it. And even then, it's questionable as to whether you're viewing that division right on the very edge or whether you're using too much sharpening in your software.
Now, Noel, that image is almost as good as one of my phone images of Saturn.
It's almost there.
Almost.
Well, you can see some equatorial banding there. So
yeah.
What do you think, Perry? Have you got anything to add about Cassini, the astronomer?
There was a bit of a dynasty of Cassinis actually at Paris Observatory, because his son took over from him. And of course, as you said, those telescopes were particularly unwieldy at that time. They were incredibly long to try and get more magnification. And it wasn't until telescopes improved that we started getting better detail on the surfaces of planets and seeing the rings in better detail as well through the 1700s when telescopes improved.
I think there was a Dutch gentleman by the name of Hevelius. Is that correct? Have I pronounced that right?
Do you mean Huygens? Huygens was the
No,
first.
not Huygens. There was a Hevelius or something, and he made
Yeah,
one of
Hevelius.
these single lens, and it was 150 meters long, or something like that. It was ridiculously long, and he used ropes, and it was an open tube.
Yep.
But
There
you're
we
correct,
go.
Perry. And until the 1700s, really, they were they didn't really understand telescopes enough.
All right.
And
I think
they couldn't make them as to a finer figure as they wanted. That was
No.
the other. Well, that's a good one to finish on, Mark.
it's a cracker to finish on. So thank you very much for that, Noel. So let's, whoop, no, let's do that. Ron's hiding in the background there. I can see him with his red light disco lights going on. So
Yes.
thank you everybody for coming along. Thank you, Noel, for bringing your telescope along. Thank you, Andy, for your telescope as well. And thank you, Ron, for your telescope.
Yes.
And thank you, Perry and Stuart, for your knowledge as well, for sharing your knowledge with us tonight.
Thanks very much.
And for those of
Thanks,
you,
everyone. Yeah, good fun.
it was, wasn't it? It was great fun. And for those of you who aren't members of the ASV yet, you can join us at www.asv.org.au/join. I know we had someone join about 10 or 15 minutes ago. I saw a comment asking how to join, and then they said they joined, which is wonderful news. We have another new member. Now, we do have a Halloween full moon live stream planned if the clear clouds stay away. So keep an eye out for that one. That'll be, so that's about 2-3 weeks away.
I believe it might be a blue moon, Mark.
It is a blue moon, and apparently the last blue moon on Halloween was 1944. So
the blue moon thing is
yes,
very interesting, or it has a very interesting history. Of course, the moon doesn't all of a sudden turn blue, but farmers back in the 1800s needed to know whenever there were 2 full moons, well, actually, when there were 4 full moons in the one season, because it meant that they would get extra time out in their fields, especially during the harvest, because an extra full moon allowed them to do late picking and all of those things. So the almanac that farmers used to get, the guys that printed the almanac, now this may be a little bit apocryphal, but I believe it's true. The moons, the 3rd moon, full moon in a season of 4 moons was inked in blue ink. And that's where the terminology for a blue moon comes from.
there you go.
Now,
I did not know that.
Unfortunately, in the 1940s, there was an article written by somebody in Sky and Telescope, and they got it wrong, and it's stuck ever since, that it's become 2 full moons in the 1 month, when in fact, originally it was 4 full moons within a 3-month season. But anyway, both of them are valid, and it means we've got something to look forward to.
There we go. So that'll be our next live stream. So I'm pretty sure we'll all be in the same position in this time in 3 weeks' time. So come along and have a look. And if you're not an ASV member, join us tonight. www.asv.org.au/join. And
Mark, do we have to dress in Halloween attire?
you know we're going to have to. We cannot have a Halloween live stream full moon and not be in Halloween attire. Noel, if you do not come as Uncle Fester, I will be disappointed. So there we go. And everybody else who comes along has to dress up in Halloween gear and post a photo of themselves during the live stream. That's
Sounds good.
That's it. That's the goal for next month. So keep an eye out for that stream. We'll post about that over the weekend as to when that's going to occur, and come along. And thank you very much for coming along tonight. We'll see you later.
Thanks, guys. Good night.
Bye.